Okay, some of you have had some questions on 67. It's a little bit of a challenging problem because in order to put this polar equation into rectangular in terms of x and y's, you have to get rid of the 3 theta. So here's what I did. I thought of 3 theta as 2 theta plus theta, and then I used sine, cosine, cosine, sine. So I used my sum and difference formula in order to break that down. Now, sine 2 theta is a double angle. So I'm going to substitute in 2 sine theta cosine theta. Now you have to multiply it times that cosine theta, so that's going to be squared. Plus, I'm going to rewrite cosine 2 theta as cosine squared theta minus sine squared theta. Carry down my sine squared theta. Okay, in my next step, I'm just going to distribute that over. So I have 2 times 2 sine theta cosine squared theta plus sine theta cosine squared theta when I take sine theta times cosine squared minus sine cubed theta when I take sine theta minus sine squared theta. These are like terms. So I have r equals 2 times 3 sine theta cosine squared theta minus sine cubed theta. And now I'm going to distribute the 2. So I have r is equal to 6 sine theta cosine squared theta minus 2 sine cubed theta. All right, so you really at this point could multiply each side by r cubed, but I'm going to do this just in a few more steps so that you follow what I'm doing. If I multiply each side by r, then I get r squared is equal to 6r sine theta cosine squared theta minus 2r. And I'm purposely going to write this as sine theta, sine squared theta, just so visually it makes sense. I don't need a parentheses there. Okay, I'll deal with the r squared a little bit later. But I end up with r squared is equal to, I can substitute in y for r sine theta, cosine squared theta minus 2, I can substitute y in sine squared theta. Okay, I still have thetas I have to get rid of, so I'm going to multiply both sides by r again. So I get r cubed is equal to 6yr, and I'm going to write this as cosine theta times cosine theta instead of cosine squared theta, just so visually you understand what I'm doing, minus 2yr. I'm going to do the same thing. I'm going to rewrite sine squared theta as sine times sine. So now I've got r cubed is equal to, this is an x, so I have 6xy cosine theta minus 2y squared, because this is a y, sine theta. And now I'm going to multiply both sides by r again. Again, at this step up here, you could have multiplied by r cubed on both sides and take care of it a little bit quicker, but I just thought I would explain in case it wasn't intuitive. So I have r to the 4th is equal to 6xy r cosine theta minus 2y squared r sine theta. So r to the 4th, you can think of that as r squared squared. So it is x squared plus y squared, the quantity squared, equals 6x squared, because this is another term for x, y, minus, there's another y, 2y cubed, and you are finished. We now have an equation that started out as r equals to sine theta in polar, and now we have it in rectangular. And here's some homework help on problem 69. What I can do is I've got r equals 1 over 1 minus cosine theta. This is in polar form, and we have to turn this equation into rectangular form, meaning we only want x and y's in that equation. So I'm going to go ahead and cross multiply. So I have r times 1 minus cosine theta equals 1. So I have r minus r cosine theta equals 1, and I can substitute in x for r cosine theta. Sorry, that should be a minus. All right, so if I get r by itself, I get r is equal to x plus 1. So again, kind of that ingenuity piece, I can substitute in for r. I know that r squared is equal to x squared plus y squared, so that means r is equal to the square root of x squared plus y squared, which can be written as x squared plus y squared to the 1/2. Why would I do that? Because at this point, if I would multiply both sides by r to try to get this to be an r squared, you end up with an r on the other side, and you don't end up with an r squared. So I'm going to rewrite r as x squared plus y squared to the 1/2 And if you don't like that 1/2, remember, since this is an equation, whatever I do to one side, I can do to the other. So I'm going to go ahead and square both sides. So 1/2 squared just yields x squared plus y squared, and that's going to equal x squared plus 2x plus 1. The x squareds on either side cancel, so I'm left with my final answer that r equals 1 over 1 minus cosine theta is equivalent in rectangular coordinates or rectangular equation to y squared equals 2x plus 1.